Hello and welcome to our online recorded session on geometric sequences. In this session, we'll explore the fascinating world of geometric sequences and dive into their unique properties. And before we begin our journey, let's establish some ground rules to ensure an engaging and fruitful learning experience. Firstly, I encourage you to pause the video whenever you feel the need to digest the information or work on the problems presented. Learning is a process, and taking breaks to reflect and absorb the concepts will greatly enhance your understanding. So don't hesitate to hit that pause button and take your time. Let's get started. This sequence here 3, 6, 12, 24, 48, and so on, as you see here. Each time we multiply by 2 to get the next term. So we multiply by 2. 3 times 2 is 6, and 6 times 2 is 12. And 12 times 2 is 24. And if we divide it, 6 divided by 3, you will get 2. And 12 divided by 6 is 2. And 48 divided by 24 also is 2. So the common ratio R is the value of any term divided by the value of the preceding term directly. Okay. So here R is equal to 6 divided by 3, which is 2. And this sequence is a geometric sequence. This sequence is a geometric sequence. If the sequence Tn is given as 2 multiplied by 5 raised to the power of n minus 1, how can we generate the sequence? So find T1 instead of n, write 1. So it will be 2 times 5 to the power of 1 minus 1, and 5 to the power of 0 is 1. So the first term is 2. The second term, put instead of n2, it will be 2 times 5 to the power of 2 minus 1, and 2 minus 1 is 1. So 2 times 5 will be 10. And when x equals 3, you will get 50. So we have the sequence 2, 10, 50, and so on. We observe that each time we multiply by 5, and if we divide it, 10 divided by 2, you will get 5. If you divide it 50 divided by 10, you will get 5. So this sequence is a geometric sequence, and its common ratio is 5. And if we want to divide Tn plus 1 divided by Tn here, Tn plus 1, it's 2 multiplied by 5, and instead of n, we will write n plus 1. Okay, and n plus 1 minus 1, it will be n. So Tn plus 1 is 2 times 5 to the power of n. That's Tn plus 1. And then divide Tn plus 1 divided by Tn. That's Tn plus 1, 2 times 5 to the power of n divided by Tn, 2 times 5 to the power of n minus 1. Cancel 2 and 2. And here we have 5 to the power of n and 5 to the power of n minus 1. When dividing like spaces, subtract powers, it will be 5. So this sequence is a geometric sequence, and its common ratio R is 5. That's it. Now let's go to the types of geometric sequences. The first type, increasing sequence. The increasing sequence, let's have a look at this example. Here we have the sequence 3, 6, 12, 24, and so on. We observe that A is 3, A here is 3, and R is 2. R is the common ratio, and we have got R from dividing 6 divided by 3, 2. As you see here, A is greater than 0, A is positive, and R is greater than 1. A is greater than 0, A is positive, and R is greater than 1. And the geometric sequence is going to be increasing sequence if A is less than 0 and R greater than or equal to 0, less than or equal to 1. Let's have a look at the second sequence. Here in the second sequence, A is -6, so it's a negative number, less than 0. A is less than 0. A is negative. And here, if we want to find R, we will divide the -2 divided by -6. It's 1/3. And this sequence is increasing, -6, -2, -2/3. Each time, we will find that the sequence is increasing. So here in this sequence, A is less than 0, is negative, and the common ratio is between 0 and 1, greater than 0 and less than 1. And R here is 1/3, and the 1/3 is between 0 and 1, is greater than 0 and less than 1. And the sequence is decreasing, as a decreasing sequence. We say the sequence is decreasing. Let's have a look at this sequence here. It's 2, then 1, then half, then 1/4. This sequence is a geometric sequence, and A equals 2. So A is positive and greater than 1. And R, the common ratio, we get R from dividing the term divided by the previous term, so it's a half. So as you see here, R is between 0 and 1. R is greater than 0 and less than 1. And A is a positive number greater than 0. So A is greater than 0, it's a positive. And here this sequence, the first term is -2, then -6, then -18. As you see here, the sequence decreases. So we say that the sequence is a decreasing sequence. Look at the first term, it's a negative number. So it's less than 0, negative. And the common ratio here, -6 divided by -2, it's a 3. And R is greater than 1. So A less than 0 and R greater than 1, the sequence is a decreasing sequence. And here, we have 3, then -6, then 12, then -24. This sequence is alternating sign sequence. Alternating sign sequence. And the first term here is positive, the second term is negative, because the common ratio is negative. The common ratio R here is less than 0. So if R is less than 0, the sequence is alternating sign sequence. R less than 0. R is negative. And the sequence is constant as far as 1. And if we look at this sequence here, you will find 5 divided by 5, it's 1. So this sequence is a constant sequence. The general term of the geometric sequence. Let's study this sequence here. 3, then 6, then 12, then 24. Each time you multiply by 2 to get the next term. So here the first term is 3, and the second term is 3 times 2. 3 times 2 is 6, and the third term, 12, came from 3 times 2 to the power of 2, and the fourth term is 3 multiplied by 2 raised to the power of 3. 2 raised to the power of 3 is 8 multiplied by 3 is 24. So here, 3, we can write it as A, the first term, and the second term is 3 times 2. It's A multiplied by R. R is the common ratio. And the third term is AR to the power of 2, and the fourth term is AR to the power of 3, and so on. So T1, the first term is A, and the second term, T2 equals A multiplied by R. And the third term is AR multiplied by 2. So we can deduce the nth term of a geometric sequence. The nth term of a geometric sequence, Tn, is A multiplied by R raised to the power of n minus 1. So if I want to find T100, it will be A multiplied by R to the power of 99. If I want to find T20, it's A R to the power of 19. And T15, it's A R to the power of 14. So we can find any term, the nth term is equal to A is the first term, and multiplied by R is the common ratio raised to the power of n minus 1. So the geometric sequence is written as A, the first term AR to the power of 2, till reaching AR to the power of n minus 1. And n in this case is the number of terms of the sequence. And we can write the geometric sequence as AR, the second term, the third term, AR to the power of 2, and the last term is L. So L equals what? Equals A multiplied by R raised to the power of n minus 1. And the term before the last term is L over R. And the term before this term is L over R to the power of 2. So L, once again, is A multiplied by R raised to the power of n minus 1. Notice that we are dividing two geometric sequences, two geometric terms like T5 and T3. You know, T5 is AR to the power of 4, and T3 is AR to the power of 2. When dividing them, we are going to cancel A, and then write R subtracting powers. 4 minus 2 equals 2. Something like T13. T13 equals AR to the power of 12, and T10 is AR to the power of 9. Cancel A and A, then subtract, because we have here R and here we have R, so write R and subtract powers. 12 minus 9 is 3. We observe that if we are dividing T13 divided by T10, just write directly R and then subtract 13 minus 10. 13 minus 10, it will be 3. So here in this example, T5 divided by T3, we can write it as R and subtract 5 minus 3. It will be R to the power of 2. So T20 divided by T17. T20 divided by T17 directly, it's R to the power of 20 minus 17. So it will be R to the power of 3. And also, if I want to find T25 divided by T5, it will be what? It will be R to the power of, subtract 25 minus 5, it will be R to the power of 20. That's it. Tx divided by Ty equals R to the power of x minus y. Let's revise some factorizing. We will need them in these questions. 1 minus R to the power of 2. It's the difference between two squares, and it's factorized as 1 plus R multiplied by 1 minus R. That's the difference between two squares. And here 1 minus R cubed, and 1, it's the difference between two cubes. How can we factorize it? Take the cubic root of the first, it's 1, and take the cubic root of the second, it's minus R. Then square the first, it's 1. Change the sign between them and multiply, it will be plus R. And square the second, it will be plus R to the power of 2. And 1 plus R cubed, it's a sum of two cubes. How can we factorize it? Take the cubic root of the first 1 and the cubic root of the second R. Then square the first, square 1, it will be 1. Change the sign between them and multiply, it will be minus r, and square the second, it will be plus r to the power of 2. Here, if we want to expand these two expressions, how can we expand them? Multiply 1 by all terms here. So 1 times 1, it's 1, and 1 times r to the power of 2, it's r, and here plus r to the power of 2. Then multiply negative r by all terms here. Negative r times 1, it's negative r, and negative r times r, it's negative r to the power of 2, and negative r multiplied by r to the power of 2, it's negative r to the power of 3. And then multiply r to the power of 2 here. R to the power of 2 times 1, it will be r to the power of 2. And r to the power of 2 multiplied by r, it's r to the power of 3. And r to the power of 2 multiplied by r to the power of 2, it's r to the power of 4. Then tied it up. We have here r, here, and minus r. They are going to be cancelled. And we have r squared and negative r squared, cancel them. And also you will find the negative r cubed and r cubed, they are going to be cancelled. We ended up with 1 plus r to the power of 2 plus r to the power of 4. So we reached to a conclusion. You should be familiar with it, which is 1 plus r to the power of 2 plus r to the power of 4 can be factorized as 1 minus r plus r to the power of 2. And change the sign, write it again, 1 plus r plus r to the power of 2. Try to keep them well, because you will need all of these notes when solving problems. Now let's go to the geometric means, and let's have a look at the sequence 2, 6, and 18. A here is 2, and the common ratio is 3. Okay, and we will find that this mean here, the geometric mean is 6. This 6 is equal to the square root of 2 multiplied by 18. 2 multiplied by 18 is 36, and the square root of 36 is 6. And if we have a sequence like this one, A is 2 and R is negative 3. So the sequence is 2, negative 6, and 18. And this negative 6 came from what? The negative square root of 2 times 18. 2 times 18 is 36, and put negative in front of it. So if we have 3 terms like A, B, and C, how can we get the geometric mean of this sequence? The geometric mean of this sequence is positive or negative the square root of A multiplied by C. Once again, the geometric mean for this sequence is positive or negative the square root of AC. How can we get the geometric mean of some positive? Some positive, they must be positive quantities whose number is n. So here it's the nth root. The nth root of what? Of the product of these numbers. So if I want to get the geometric mean of these numbers, so count them. How many numbers we have? 1, 2, 3, 4, 5, 6. So you will find the 6th root. You will find the 6th root of the product of these values. So it's the 6th root of 2 times 4 times 6 times 9 times 36 times 3. It's going to be 6. And here, if we have 3 values like A, B, and C, what is the geometric mean of these values? It's the cubic root of the product of them, A, B, C. And if we have 4 values like A, B, C, and D, what is the geometric mean of these values? It's the 4th root of A times B times C times B. And if we have 3 values, A, B, and C, what is the arithmetic mean? The arithmetic mean B is A plus C divided by 2. That's the arithmetic mean. And the positive geometric mean B is the square root of A multiplied by C. So we have here 2 values for B. And here's the geometric positive mean, and here it's the arithmetic geometric mean. I want to compare between them, between the arithmetic and geometric, which is greater, which is the smaller. Let's subtract the arithmetic mean minus the positive geometric mean. And the arithmetic mean, as you know, it's a plus c divided by 2, and the geometric mean, it's the square root of ac. So here we can write the square root of ac divided by 1 and subtract them, multiply here by 2 and 2. So it will be a plus c over 2 minus 2 the square root of ac over 2. Write 2 here in the denominator and then subtract. It's a plus c minus 2 the square root of ac. Rearrange them. Write a at the very beginning minus the 2 square root of ac plus c all divided by 2. You know, this expression is a perfect square, and this expression can be factorized as the square root of a minus the square root of c all raised to the power of 2 divided by 2. And if you tried here, if you tried to find the value of the square root of a minus the square root of c to the power of 2, because this expression raised to the power of 2, so it's a positive all the time. And positive value divided by 2, if we have a positive value divided by also a positive value, so it's greater than 0. So the geometric mean is smaller than the arithmetic mean, and the arithmetic mean is greater than, because when subtracting the arithmetic minus geometric, we have got a value greater than 0. A geometric sequence, the sum of its first and second terms is 3. The sum of its first and second terms is 3. And the sum of its first and fourth terms is 63. Find this geometric sequence. Because the sum of the first and second terms is 3, so T1 plus T3, we'll write 3. And T1 is A, plus T3 is AR to the power of 2 equals 3. We can take A as a factor, so you are left with 1 plus R to the power of 2. Here it's the second term, sorry. So it's a T2, not T3. So here it's AR. So here A, the first term is A and the second term is AR equal 3. A is a factor, so you are left with 1 plus R equals 3. That is equation 1. Equation 2. The sum of the first and fourth terms is 63. So T1 plus the fourth term. The fourth term here is 63 to T4 equals 63. T1 is A and T3 is AR to the power of 3 equals 63. We can take A as a factor. So you are left with 1 plus R to the power of 3 equals 63. That is equation 2. So here we have two equations. How can we get R from these two equations? We can get R from dividing both of them, dividing the second by the first. So divide 2 divided by 1. So it will be A multiplied by 1 plus R to the power of 3 over A multiplied by 1 plus R equals 63 divided by 3. Cancel A, and 63 divided by 3 equals 21. So 1 plus R to the power of 3 over 1 plus R equals 21. Then we can factorize 1 plus R to the power of 3. It's sum of 2 cubes. as I explained in the previous examples. So here we'll take the cubic root of the first and the cubic root of the second, and here square the first. 1 to the power of 2 is 1. It change the sign, then multiply minus r plus r to the power of 2, all divided by 1 plus r equals 21. Cancel 1 plus r and 1 plus r. So we ended up with r to the power of 2, 1 minus r plus r to the power of 2 equals 21. Move 21 to the next side and rearrange this expression. It will be r to the power of 2 minus r plus 1 minus 21 equals 0. Then it's r to the power of 2 minus r. Because we have here 1 and negative 21, it will be minus 20 equals 0. It's a quadratic equation. We can factorize it. Two numbers, their product negative 20 and their sum negative 1. So it will be r minus 5 and r plus 4 equals 0. Then we have two solutions here, or we have two geometric sequences. The first one is r minus 5 equals 0. From that, r equals 5. And the second one is r plus 4 equals 0. And from that, r equals negative 4. Okay. And we know that from equation 1, that a multiplied by 1 plus r equals 3. A multiplied by 1 plus r equals 3. So we can get a from this equation. Just put r equals 5. So a multiplied by 1 plus 5 equals 3. And a multiplied by 6, 6a equals 3. From that, a equals half. So the equation will be half. The geometric sequence will be half the first term, then multiplied by 5, it will be 5 over 2, and multiply again by 5, it will be 25 over 2, and so on. That is the first sequence. And the second sequence, here it's r equals negative 4 from this sequence. So just to put r equals negative 4 in this equation, a multiplied by 1 plus r equals 3. Instead of r, write minus 4. So it's a 1 minus 4 equals 3. So 1 minus 4 equals negative 3. So it's negative 3a equals 3 divided by negative 3. So a equals negative 1. So the sequence will be negative 1. A is negative 1, then multiplied by r equals negative 4. So negative 1 multiplied by negative 4, it will be 4. Multiply again by negative 4, it will be negative 16. And so on. A geometric sequence whose all terms are positive. And its first term is 4 times the third term. Okay. So first term is T1 equals 4 times the third term, it's 4T3. And T1 is A equals 4 multiplied by AR to the power of 2. Divided by A both sides. So 4A to the power of 2 equals 1. Divided by 4. So R to the power of 2 equals 1 over 4. From that, we have two values for R. It's a half, or r equals negative half. And negative half in this case refused because all terms are positive. So we are going to cancel this value. And the sum of the second and fifth terms is 36. The sum of the second, T2, and the fifth, T5 equals 36. So T2 is A, R, plus T5 is AR to the power of 4 equals 36. A is given as, I want to get A, and R is half. So A multiplied by half plus A multiplied by half to the power of 4 equals 36. So half a plus 1 over 16a equals 36. Okay, we can multiply by 16 all times just to cancel this these fractions. So it will be, if we are going to multiply by 16, or we can add half to 1 over 16 by multiplying by 8. Actually, I don't like using the calculator. 8 times 1 is 8, and here it's 16, so 8 plus 1, it's 9 over 16a equals 36. Then to get a multiplied by 16 over 9, so here 9 over 16a equals 36. Multiply here by 16 over 9, and here by 16 over 9. Cancel them. So a equals 36 again times 16 over 9 divided by 9, 1 divided by 9, 4. So a equals 4 times 16 is 64. Now we can write this sequence. It's 64. Then multiply by half 32. Then multiply by half 16, and so on. That's it. Find the two numbers whose arithmetic mean is 5 and their geometric mean is 3. So the arithmetic mean equals, it's x plus y divided by 2. So 5 equals x plus y over 2. Do cross multiplying, so x plus y equals 10. And the geometric mean is the square root of x times y. And here 3 equals the square root of x times y. So squaring both sides, so xy equals 9. Okay. So here from this equation, x equals 10 minus y. Or y, we can get y from this equation. Y also is 10 minus x. And substitute in this equation here. Xy equals 9. We are going to write x as it multiplied by y, which is 10 minus x equals 9. So x times 10, it's 10x, and x times negative x a power of 2 equals 9. Then we can rearrange all of them, or we can move them to the next side. It will be x a power of 2 minus 10x plus 9 equals 0. Okay, then factorize. X minus 9 and x minus 1 equals 0. So x here equals 9 and x here equals 1. If x equals 9, then y equals 1. And here if x equals 1, then y equals 9. So the two numbers are 1 and 9. In this example, find the two positive numbers whose two geometric, find the two positive number whose positive geometric mean, whose positive, here it's positive geometric mean, positive, whose positive geometric mean is greater than one of those two numbers by 2 and is less than the other by 3. So let's assume the two numbers are x and y. They are the two numbers. The geometric mean is the square root of xy. That's the geometric mean of these two numbers. So the geometric mean is less than one of those two numbers by 2. So the square root of x, xy, the square root of xy, that's the geometric mean, minus any one of them. Let's say x equals 2. Okay. So the square root of xy, that's the geometric mean, minus x equals 2. And this geometric mean is less than the other by 3. The other one is y. So y minus the geometric mean xy equals 3. Okay. So I assume the two numbers x and y and the geometric mean is greater than one of them, one of the two numbers, by 2. So square root of xy minus x equals 2, and the geometric mean is less than the other number by 3. So y minus square root of xy equals 3. Add the two equations, equation 1 and here it's equation 2. Add them. So you are left with y, here it's y minus x equals, I'm adding them. So here it's y and here is minus x, and 2 plus 3 equals 5. From that, y equals x plus 5. So y equals x plus 5. If we went back to the first equation, the first equation is square root of xy minus x equals 2. So square root of xy equals x plus 2. How can we get rid of this square root? By squaring both sides. Squaring both sides. When squaring both sides, it will be xy equals x plus 2 to the power of 2. So x plus 2 to the power of 2, expand it, it will be x to the power of 2, plus here it's 4x, and here plus 4, and here it's xy. Just what I'm going to do, to write instead of y x plus 5. I'm going to write instead of y because y is equal to x plus 5. So it's x here multiplied by x plus 5 equals x to the power of 2 plus 4x plus 4. Okay. So expand. Let's expand in the next page. So it will be x to the power of 2 plus 5x equals x to the power of 2 plus 4x plus 4. Cancel x squared and x squared. They are left with 5x here, and we can move 4x to the next side. So minus 4x equals 4. 5x minus 4x, x equals 4. And y is equal to x plus 5 from equation 1. So y is equal to 4 plus 5, which is 9. Then the two numbers are 4 and 9. Insert 6 geometric means between 1 over 4 and 32. So here the first term is 1 over 4 and the last term is 32. I want to insert 6 geometric means. So the number of means is 6. So the number of terms equals 8. Number of terms equals 8. So n equals 8. Okay. And a equals 1 over 4. And L equals 32. L equals 32. So we're going to write here L equals AR to the power of n minus 1, and L is 32 equals A. A is 1 over 4 multiplied by R. You know what is R? I don't know what is R. Raised to the power of n minus 1. And n is 8. 8 minus 1 is 7. So multiply by 4 here. It will be 8, 128. So 128 equals R to the power of 7. And 128 can be written as 2 to the power of 7 equals R to the power of 7. So R equals 2. So the geometric means are half. After 1 over 4, you will multiply by 2. It's a half. Then multiply by 2 again. It's 1. Then multiply by 2, 2. Multiply by 2, 4. And 8. Then 16. They are the geometric means inserted in this sequence between 1 over 4 and 32. X, Y, Z, and L are positive quantities of geometric sequence. Prove that X plus L Prove that x plus L is greater than y plus z. You know, the arithmetic mean is greater than the geometric mean. And if we looked at the first three terms, x, y, and z, x, y, and z, y is the geometric mean of these terms, x and z, because y is in the middle. So y is the geometric mean. And the arithmetic mean of x and z is x plus z divided by 2. So x plus z divided by 2, that's the arithmetic mean, is greater than y, is greater than the geometric mean. It's greater than the geometric mean. So x plus z do cross multiplying is greater than 2y. That's equation 1. And if we looked at y, z, and L, they are three terms of a geometric sequence. So z in this case is a geometric mean. Is a geometric mean of y and L. So y plus L divided by 2, that's the arithmetic mean. The arithmetic mean is greater than the geometric mean. So y plus L over 2 is greater than 2z. That's equation 2. Adding 1 and 2. So it will be x plus z plus y plus L is greater than 2y plus 2z. Once again, x plus y plus x plus z plus y plus L. Let's write here. X plus z plus y plus L is greater than 2y plus 2z. Or we can here subtract y here, subtract z, and subtract y here, subtract z from both sides. Cancel z and minus z, cancel y and minus y. Then you are left with x plus L, and the left side is greater than 2y minus y. It's y plus 2z minus z. Or we can move y to the next side, move z to the next side. You will end up with x plus L is greater than y plus z. I hope you enjoyed this session. Please do the exercise of the geometric sequence. Practice makes perfect. See you in the coming episodes. Goodbye.